Today is the 7th of September 2023, and I'm going to discuss travel graphs with you. Before I start the lesson, thank you to everyone who has been watching the videos. Please, if it's your account, consider subscribing, sharing, liking and following us, okay? And if it's not your account, please ask for permission, okay? I'll appreciate it very much. I normally write in the comment section, please follow my notes/scripts, okay? So, for instance, this is 4/9. So if I'm explaining something in this context, it will be 4/9, okay? So if it comes out, for instance, as 5/9, and I'm not in this section yet, please don't assume, okay? It will be 4/9. It will be 4 and 9, okay? And that will be 1100, 1150, okay? Thank you very much on that. Beware of scammers, okay? They are all over the place. They do it to me online, okay? They do it to as much as naive people. Don't fall for it. If somebody asks you for a friend request, get access to your messenger, can you donate money for this platform? It's not me. Can you donate money so we can send it to a charity? It won't be me. Can you give us money so we can send it to an orphanage or some amputee or some seriously ill? It's not me. Don't fall for it. Report them or just block them. The chances are, even if you block them, they will create another account, but just keep on blocking them or report them, okay? Thank you very much. Recap. Last lesson, we were looking at the line of best fit for positive correlation and negative correlation. So I brought a graph, two graphs, positive, okay? So as one data increases, the other increase, and the negative one, as one data increases, the other decreases. And we explain the term positive correlation, whether it's strong. The stronger it is, the easier it is to draw your line. And then we said that if there is time, you can use your calculator to find the mean of the data, and then you use that point to plot on the graph. And after you've drawn your scatter diagram, your line should be go through the mean point that you found on the calculator if you do it right, or closer, okay? And or you can use eye judgment if you have time, okay? And then you plot the graph with pencil, give a title, label the axis, make sure you have equal scale, okay? Examine the data if you need to start from 0, 0, the origin. If not, use this sign to shorten the graph, okay? This sign here, so that you'll be able to access, you can able to use a bigger portion of the graph, okay? Now, the starter I have for you today will be Sarah and Susan share 11 £1,150 in the ratio 4:5. How much will each of them have? Okay, that is the question. So we have Sarah and Susan in the ratio 4:5. So the total ratio of sharing will be 9. Okay, so Sarah will have 4 divided by 9 times 1150. Okay, so if you use the calculator, you get 4,600 divided by 9. So Sarah's portion will be 511.11 pence. This is money, and you can have 11 pence. So we can leave our answer as this, unless you are asked to give the nearest whole amount. But here you can leave the money as this. Okay, Susan also 5/9 times 1150. So on the calculator you have 5750 divided by 9. So Susan will take 6,038.89. Again, this is money. 89 pence. You can get that in real life. So unless you are asked to approximate in the question, okay, to the nearest whole number, this will be your answer. And if you add both, you should end up getting 1,150 pounds, which I did on the calculator, and I got that. Okay, today's lesson we want to talk about travel graphs. So I'm going to talk it to you step by step, but in an exam you only need to do the one graph. So before you start, you need to do the math first. I'll tell you in the end what I mean by that. Okay, but I've brought it in step to show you how to do a travel graph. Okay, so but if it's a question, we'll just draw the one graph. Okay, so this example, it has to do with Amelia has to travel from her house for a meeting. Okay, the meeting is 8 kilometers and she has about 30 minutes journey by car to get to the meeting. So the first part of the travel graph, okay, so in my x-axis I have the time in minutes, and then in my y-axis I have distance in kilometers. So she's going to travel 8 kilograms for 30 minutes. So here my time is in minutes, so that is 30 minutes and that is 8 kilograms. Look at the y-axis. This is not to scale, but I've done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it's not on the graph, it's just on plain paper, and that is my label for the y-axis. That's my, so if you look at my graph carefully, okay, on the x-axis in minutes I have 5, 10, 15, 20, 25, 30. So she's going to leave her house, travel for 8 kilometers, okay, to get to the meeting. So this is the first part of the travel graph, which I've labeled 1. So I use broken lines or a faint line. Okay, you can use broken, but this is not part of the graph, so make it as faint as possible. And then this is where she gets to. So from her house, she travels 8 kilometers there, and it takes her 30 minutes to get to the meeting. So from 0, I draw my line. So this is her first travel journey. Then the second part, okay, the meeting is 1 hour, which is 60 minutes. So the first journey took 30 minutes. Okay, the meeting is 60 minutes. So now she will use 90 minutes. Okay, that is 90 minutes. Okay, she will use 90 minutes. So 30 at 60 is 90 minutes from her house. Okay, so I have to look at the x-axis now. Look, so the first 30 minutes she gets the meeting, and then she is at the meeting for 90 minutes. For 60 minutes, that is 1 hour, which takes her to 90 minutes. So it is 90 minutes there. So I find 90 minutes there. Okay. And then she's not traveling. She's at the meeting. So that will be a straight line from there. Okay. So this is the meeting time, 1 hour, 30 to 90 minutes here. So this is the second part. Okay, so the first part, that is her journey. Okay, we are talking about travel graphs. Okay, so the journey, that is the meeting part, the second part. So at the end of the meeting, after 1 hour, Amelia leaves and travel for 2 kilometers, which takes her 15 minutes to get some groceries. Okay, so Amelia leaves the meeting at the end of the meeting and travel 2 kilometers for 15 minutes to get some groceries. So now she's going to travel 2 kilometers, which will take her 50 minutes. Now, if you add 2 kilometers to the 8 kilometers she's done, she's going to do 10 kilometers now. So now, from 10 kilometers, okay, from 10 kilometers, she's going to travel 15 minutes. And if you add 15 minutes, yeah, so 10 kilometers, if you add 15 minutes to the 100 and the 90 minutes, she's now at 105 minutes. So from the 90 minutes, in 50 minutes she'll be here 105 minutes, but she will travel another 2 kilometers. So 8 plus 2 is 10 kilometers. So there you use a faint line because that's not part of the graph, and then you connect the meeting from here to the grocery shop because she's traveling here. Okay, so that is her grocery job journey for 50 minutes in 2 kilometers. So 50 minutes here, I have 105. Okay, 2 kilometers, add 8 kilometers. Now she's at 10 kilometers. Label your y-axis and your time axis. Okay. Now, Amelia was in store for 40 minutes. So to get the grocery, she got to the shop, which is the third part, which we have seen. Now she was there for 40 minutes. So for 40 minutes, she's not traveling. Okay? So 40 minutes add to her already 105 minutes will give you 145 minutes. So on the x-axis, we need to extend her time to 145 minutes. So I've used 10, 20, if you look at it, up to 140. So between 140 and 150 is 145. So I use a fixed line, okay, because she's at the grocery meeting, she's not traveling. So she's still 10 kilometers away, okay. So now that will also be a flat line again. So that is a fourth part of her day. Okay, that is the fourth part of her day. Now, the fifth part. So now from the grocery shop, Amelia traveled another 20 minutes, which is about 4 kilometers, to collect her son Jason from school. Okay, so now the first part is the journey to the meeting. The second part is the meeting. Okay, the third part is the journey to the groceries. The fourth part is in the grocery store. Now the fifth part is where she travels 20 minutes, 4 kilometers to pick a son. Okay, now we are already at 10 kilometers. So 10 add 4 is 14. So we draw a faint line here, okay, and that will take us to 165 minutes, because we've already done 145 minutes plus 20 minutes will give 165. So now from there, okay, from the grocery shop, we travel for 20 minutes, which will take us to 165 minutes, which is between 160 and 170 minutes. Our x-axis time is in minutes, okay? So far with Amelia, from home, in the meeting, travel to the grocery store, in the grocery shop, travel to Jason's school, okay? Now, at Jason's school, Amelia was there for 50 minutes, okay? Normally, you get there and then you pick your son, okay? So here, they could ask you a question like, when was Amelia at Jason's school? If she left home at maybe 12:30, and you have to use this time frame to answer that, okay? So now she's in Jason's school for 15 minutes. So on the graph again, that is 14 kilometers. So we trace it all the way there. She's not traveling here, and that is a 15 minutes. So 165 plus 15 minutes will be 180. So if you can see here, okay, 165, okay, plus 15 minutes. There, 165 plus 15 is 180. So from 165, okay, and 180, she's there waiting to collect Jason back home. Okay. Now, then from there, she leaves. From there, she travels back home. Okay, she travels back home with Jason, but because there's traffic now, she has to take 75 minutes to get home. So now 180 minutes at Jason's school plus 75 minutes, which will take her to 255 minutes. Okay, and she's 14 kilometers away from home. Okay, so now she picks Jason from school, and under traffic condition, she has to travel back home. And then it took her 75 minutes. So 180 minutes plus 75 minutes will give you 255 minutes. Okay. So now, here you are. So from Jason's school, okay, so we ended here. Okay, we add 175 minutes to 180 minutes. It takes us to 255. Okay, so from Jason's school all the way down 14 kilometers back home. Okay, so if you can see, this is my final time graph. Okay, so normally you don't have to draw all the graph. I'm trying to explain to you. So this is the first part, from home to meeting, had a meeting, from meeting to grocery store, spend some time in grocery store, she's not traveling, travel to Jason's school, use that time, which is a flat line. Okay, anytime she's not traveling is flat line. If she's traveling, then you need to it should have some gradients. So far she's been traveling away from home and stationary and making some stops. Now she's finished all her rounds, picked the son, and now she has to travel all the way back home. Okay, so there. So if you see, from the time she left home, she's used 255 minutes outside. So a question, so this is the graph. You only have to draw the one graph. You don't have to draw all. I'm just trying to explain to you how we arrived at this graph. So I had to draw it for you in step to understand. Okay. So now, if Amelia left home at 2:30, what time did she get back home? Okay, so we know that in total she's been outside for 255 minutes. Okay, now how do you do that? She starts at 12:30. First of all, you want to convert your 255 minutes into hours, okay, and minutes. Now 255 minutes, 4 hours is 240. So you have 15 minutes left. So in hours is 4 hours and 15 minutes. Okay. So if she left the house at 12:30, 4 hours from 12:30 will be 16:30, plus the extra minutes will be 16:40. 4:45 p.m. So she will get home around in the late afternoon at 4:45. Okay, this is the time she's going to get home. Okay, so these are the type of questions, or they will ask you, they will miss something out in the distance and ask you to find that. But if you look at it before you start, because look at the beginning of my graph. Okay, I started the time axis as 5, 10, 15, 20, 5, 10, 15, 20. But I realized that if I do that, I will end up needing more space. Okay, look at it. So by the end of the graph, I had to do a scale of 10, 20, 30, 40. This, you should be able to do the math and easily see. Okay, for explanation purpose, I had to do that. Okay, now with the y-axis, nothing really changed. Okay, because it wasn't increasing much. She did 8 and then 10 and then 14 and back home. So the scale for the y-axis is the same. So if you calculate, do the math before you start the question, which it should take you maybe 3 minutes to figure out, or 2 minutes, then you can straight away start your exercises in 10, 20 instead of 5, 10. Okay, so if you do that, you can compress the distance and use most of your graph. Okay, so you can see, but I did it for explanation purposes, to explain to you how it's important to plan from the beginning. Time graph questions are fairly easy. If they're not traveling, it's a flat line, a straight flat line. If they're traveling, you find the time and the kilometers or the distance and plot it. So this is another type of a topic that you can get a full marks if you do the math quickly, early, so that you don't do the graph, use a scale and then realize. So if I had a question like this, I would calculate all the journey and put them this thing. Normally they will give you 3, maximum of 3 or 4 in Gcse level. Okay, but for explanation purposes, I wanted to show you. So Amelia, she didn't just leave the house, spend all the time at the meeting and came back home. She had other things to do. That day she had to go to the grocery store. That day she had to pick her son. Okay, she didn't have to take her son to school. Okay, maybe the nanny or somebody, or her partner or somebody, or Jason's dad took Jason to school on his way to work. But Amelia had to collect Jason that day. Okay, so because of that, she had to do extra mileage. Okay, but at the end of the day, she got home, and because of coming home under those traffic conditions, she got home quite late. Okay, so now this is how you do a travel graph. Okay, so I've just used all the graphs to explain to you step by step. So this is the first part. The second part, the third part, the fourth part, fifth, sixth, and the seventh part. And then the question last is, so we now know that they gave us the time that she left home, and she's used 4 hours 15 minutes outside. So if she left home at 12:30, then she got home at 4:45. Okay, so this is a fairly easy topic. If you can initially calm yourself down, do the maths, figure out your axis, because that will be the difficult part. Figure out the intervals you should use, okay, and then you start plotting. So if you do that, you do this on one graph, less than 5 minutes, and then you can figure out the time. Okay, if you are not good at it, just divide by 4. So on your calculator you get 4 hours, and then figure the 15 minutes. Okay, so you just take 4 hours is 240 minutes. 240 minus 255 is left with 15 minutes. Add that to the time she left home, and that will be the time she'll be back home. Okay, so this is what I wanted to show you today. Okay, thank you for watching today's lesson, and I will see you in the next.